All right, so in this first section of 1.5, we're going to talk about really just some basics of inequalities. A lot of it's going to be a refresher, a little reminder of stuff that you did from Algebra 1. So we're going to do the one step first, and then the next section will be the multi-step. So first thing we need to talk about is the relationship between two numbers. So say you have two numbers, doesn't matter what numbers they are, any numbers at all, one of the following things is going to be true. Either A is less than B, or they could be the same number, and A could be equal to B, or A is greater than B. So we say exactly one is true because it's not possible for any of those two things to be true at the same time. Either a number is less than another number, equal to the other number, or greater than the other number. So these two are our basic inequalities. We also have less than or equal to, as well as greater than or equal to. That will be coming up shortly. The first thing we're talking about is this property of inequality that we have right here, the addition and subtraction property of equality, and it looks something like this. If you have an inequality like this, if you add the same number or subtract the same number from both sides, it doesn't change the truth of the inequality. So it looks something like this. Start with addition. So let's do an example just using less than, and then just know that it'll be the same for greater than, or less than or equal to, or greater than or equal to. So then this is true. Or this is true. So it's saying if we know that this is true, if you add the same thing to both sides or subtract the same thing from both sides, it's not going to change the answer. All right, so I'll write it for greater than, just so I don't throw you off. So if A starts off being greater than B, the exact same thing will hold. I can add the same thing to both sides or subtract the same thing from both sides, and the inequality won't change. So A plus C would still be greater than B plus C, or A minus C would still be greater than B minus C. Okay, so here's a really good example I want you to think of. Say like me and you, whoever you are, say that either I have more money than you, or say that you have more money than me. Not overall in our accounts, just say like in our hands. If someone takes away $5 from both of us, whoever has more is still the same. Or say someone gives $5 to both of us, whoever has more is still the same. You know, say I start off with 20 and you start off with 25. If someone takes 5 away from us, then I have 15 and you have 20, you still have more than me. So adding or subtracting, as long as it's the same on both sides, doesn't change the less than or equal. Or it doesn't change the less than or the greater than. Okay, so just to review, we're going to write down a couple of inequality symbols here and kind of what they mean. Should be straightforward, you should remember it, but just in case. Okay, so this one right here is greater than. This one is less than. Some people have seen these symbols a million times, yet they still mix them up, so we might as well just write them down. I've always remembered this one by thinking it kind of looks like a crunched up L for less than. And then this one, if you throw the little line underneath, and this is greater than or equal to. So this is like half of an equal sign down here, and then this one is less than or equal to. Might not be a review that you need. Maybe you know those super well, but I'm sure there are at least a couple of you that needed that. Okay, so this example, we are going to solve this inequality and then graph. So we're going to do a little review of how to graph on a number line as well. So this process basically works the same as solving equations. We're still trying to get the variable by itself on one side. So let's start by subtracting 4y from both sides. Okay, just because the 5y is bigger, doing this way kind of saves us from dealing with any negative variables. So here I have a -3. Make sure you keep the negative in front of it. And then less than 5y minus 4y gives me y. And then plus 2. So the next thing I'm going to do is I'm going to subtract the 2 from both sides so that I can get the y by itself. Okay, so this will cancel. So -3 minus 2 gives me -5, which is less than y. So if we say that -5 is less than y, if we read it in reverse order, what that actually means is that y is greater than -5. So if -5 is the smaller of the two, that means that y is the greater of the two. So normally you want to write it like this. So this is your answer if you're writing it out in symbols. We also want to see it drawn out as a graph. Okay, so start with a number line. And now I am not going to get fancy at all about what you need to put on the number line. I don't need you to actually write like -5, -4, -3, -2. I don't need that at all. All I want to see is the 0. I want to see the 0 on there. So a lot of times people just put the 0 right in the middle. And then make sure that this number appears on the correct side of 0. So -5 would be over here. So again, that's really all I need to see. I need to see the number in question, and I want to see where it relates to the 0. So what you do is you start with a circle. There's going to be a circle on this number. It's either going to be an open circle or a closed circle. So let me write down here just as kind of a reminder, and then we'll graph it. So a review. A circle, or I guess we could say an open circle. So like this is used for a less than or a greater than. And then a closed circle so like this, actually shaded in, you'd use that for less than or equal to or greater than or equal to. So basically, if -5 is what you're supposed to be bigger than, it's not actually going to be equal to -5. So we want to mark the -5 on our number line because it's an important number. We just don't fill in the circle because it couldn't be equal to -5. All right, and then greater than means any number greater than -5. Greater than means you shade to the right. Okay, so it's going to look something like this. And then I usually kind of shade the arrow too, just to show that it keeps on going forever in both directions. Okay, so anything that's bigger than -5 is now shaded here, but the -5 itself is not circled in because it's not included in my inequality. All right, so it looked like that. Make sure you write this down for a little reminder for yourself because we're going to carry that on through the rest of this section. Okay, next, multiplication and division. Now, addition and subtraction is super, super easy. Multiplication and division have slightly more complicated rules. So as long as you're talking about a positive number, nothing changes. So we can start by saying if A was less than B, if you multiply or divide by a positive number, nothing changes. So you can multiply by a positive number and nothing changes, or you can divide by a positive number and nothing changes. Okay, or really quickly, let's write the scenario if A started off being greater than. Again, you can multiply by a positive number and nothing changes, or you can divide by a positive number and nothing changes. Okay, now here is a rule that I'm sure you guys remember. If you divide by something negative, or if you multiply by something negative, the symbol will switch. Okay, so if A started off being less than B and you multiply by a negative number, the inequality will flip. If you divide by a negative number, the inequality will flip. This is a super, super, super important rule. If you multiply or divide by a negative number, the inequality will flip. Okay, so say A starts off being greater than B. If you multiply by a negative number, the inequality will flip. Or if you divide by a negative number, the inequality will flip. So think about this. Let's go back to the money example. Say that I have $20 and you have $25. You're in the better scenario. You would have the greater than. Say we flip those to negative numbers. Say I'm $20 in debt and you're $25 in debt. -20 compared to -25. I'm in the better scenario now. I have the greater. So if you switch them to be negative, or you multiply them by a -1, the inequality actually switches. You go from being in the better scenario, then if we switch it to debt, I'm in the better scenario. Okay, last little example here. We're trying to get P by itself. So what we do here is we divide both sides by this -0.3. Okay, so the -0.3 will cancel here. We divided by a negative number. So we know for sure that this inequality is going to flip. Okay, it went from being greater than or equal to, it is now less than or equal to. And I know I have the P by itself right here. Here's a little trick for dividing by decimals. First of all, I have a positive divided by a negative, so I know it's going to be negative. 12 divided by 3 would be 4. So 12 divided by 0.3, and I would end up with 40. Okay, so you move the decimal, but in the opposite way that you would normally do it. So if you are normally multiplying by a decimal, you would move the decimal to the right, but since you're dividing by a decimal, I'm sorry, I just mixed up my signs. If you're multiplying by a decimal, you would move the decimal to the left. If you are multiplying, you move it to the right. So 12 divided by 3 is 4, but since I'm dividing by 0.3, I move the decimal over 1, and I get 40. Okay, so this, remember, if I want to write it in the opposite order, p would be greater than or equal to a negative 40. Now graph the solution on a number line. So set up your number line. Remember, I always want to see the 0. You can use that as kind of a middle mark. Negative 40 would, of course, be somewhere to the left because it's a negative number. I have an or equal to. Since I have an or equal to, that means the negative 40 is included in my set, and so I shade it in. And then greater always shades to the right. Less than shades to the left, greater than shades to the right, because these are all the numbers that are bigger than a negative 40. Okay, so that would be your final answer.